For most of human history, people have wondered what reality truly is. In recent decades, that old question has taken a surprising new form. Could we actually be living inside some kind of simulation? This idea is known as the simulation hypothesis. It doesn't simply suggest that we can simulate things on computers. It proposes that our entire universe might itself be a simulated environment, created by an advanced intelligence using some kind of computational system far beyond anything we know. One of the most influential versions of this idea was introduced by philosopher Bostrom. He presented a logical argument rather than a claim. According to his reasoning, at least one of three possibilities must be true. Either civilizations like ours almost always go extinct before becoming advanced enough to run detailed simulations of conscious beings, or advanced civilizations exist, but choose not to run such simulations. Or if many simulations are created, then most beings with experiences like ours would actually be simulated, making it likely that we are too. The argument does not tell us which of these is correct. It only shows that one of them must be. Supporters of the simulation hypothesis often point to the rapid growth of computing power and virtual worlds. They note that if technological progress continues, humanity might one day create virtual environments so detailed that the beings inside them would not be able to tell the difference between their world and physical reality. In this view, modern video games and virtual reality systems are early, primitive examples of what could eventually become full-scale simulated universes. Some physicists and philosophers also highlight the mathematical and information-based structure of the physical world. Quantum mechanics, information theory, and models of space-time that look discrete rather than continuous have inspired the idea that the universe might behave like an information processing system. A few researchers have even suggested that certain patterns in physical laws could reveal hints of an underlying computational framework. Although these ideas remain highly speculative, others have proposed that features of information entropy might resemble optimization processes found in code or data compression, and have interpreted this as a possible sign of a digital reality. These interpretations are controversial and not widely accepted, but they show how the hypothesis continues to interact with ongoing scientific research. Despite this, many scientists and philosophers are skeptical. One major criticism is that the simulation hypothesis may not be scientifically testable. For a theory to be considered scientific, it should make predictions that could, in principle, be proven false. Critics argue that if any observation can be explained by saying the simulators designed it that way, then the hypothesis becomes unfalsifiable and falls outside traditional science. Some physicists argue that simulating an entire universe down to the smallest details would require unimaginable resources, and that such a simulation would likely show errors or limitations. Since no such signs have been observed, they consider the hypothesis unnecessary. Others add that the idea depends on speculative assumptions about future civilizations, unknown technologies, or other universes, none of which we can currently investigate. Philosophers also debate the logic behind the probabilities. The simulation argument relies on anthropic reasoning, comparing us to all possible observers across real and simulated universes. Some philosophers argue that we do not have a justified way to make such comparisons, or even to define what counts as an observer. At the same time, mathematicians have recently questioned whether a complete simulation of reality is even logically possible. Some aspects of the universe may not be fully representable by algorithms, suggesting that no computer could replicate every feature of physical reality exactly. If that is true, then a perfect simulation of our universe would be impossible from the start. Even so, not everyone dismisses the idea entirely. Some scientists treat the simulation hypothesis as a useful thought experiment that helps explore the role of information in physics, the limits of human knowledge, and the nature of consciousness. In this context, the hypothesis is not a literal claim about our world, but a conceptual tool for thinking about what a real universe actually means. Popular culture has explored this idea in dramatic ways through books and films like The Matrix and others. These stories often imagine an intelligent agent running the simulation, with characters waking up to a hidden reality. Actual scientific discussions are much more cautious and abstract, focusing on what can be known rather than on cinematic scenarios. In the end, there is no consensus. There is no solid evidence that we are living in a simulation, But there is also no definitive proof that it would be impossible. The question remains open, continuing to divide scientists and philosophers. It challenges us not only to consider whether our world is simulated, but also to think about what counts as a good explanation of reality itself.